Hello folks, wanted to talk you through one aspect of the cells booklet, which is the second half of it, which is all about methods of studying cells. Because we're talking about microscopes at this stage, and there's one particular skill you guys need to be able to demonstrate, which is to be able to comfortably work out either actual size or magnification when you're looking at images, pictures taken down a microscope. So these pages of the booklet are designed to help with that. The initial bit is there to introduce you to the idea that we have light microscopes, which are the ones you probably used at school, and electron microscopes, which you almost definitely haven't used. And it's also there to get used to some of the units. Now, obviously, when you're looking down a microscope, you're seeing structures that are very, very small. So the units we're used to, kilometers, meters, and even millimeters, are not going to be much use at all. So we're going to introduce these two. This is micrometers here, this funny little U symbol. It's a Greek letter, but that stands for micrometers, which is basically a thousandth of a millimeter, and then nanometers. And we need to be comfortable in using those. As you go through the booklet, you'll find pages that introduce you to some of the key terms, things like the object, the image, the magnification, the resolution. So all of this is very straightforward, but there is one part that it does bear to have it is worth having a bit more attention to. And it's this bit here, when we start talking about the magnification equation. Now, if you think about what a magnification is, it basically, it's an image, isn't it? It's a picture of an actual object. The image is larger than the actual object. You know, that's how we can look at single cells. So what you're essentially doing is you're taking an actual object and you're making it larger by some factor, and we call that factor the magnification. Okay, there we go, just about fitted that on. So image is equals actual times magnification, or I equals A times M. This is an equation that you need to be comfortable using. And not just using, you need to be able to rearrange it as well. So in a flashback to your GCSE physics or GCSE science exams, we're going to use one of these triangles for rearranging. And what you've got to do is you've got to put these three things, I, A and M, in there so that you can comfortably rearrange it. And the way you do it is I goes up there, A, M. Just remember, I am not going to get any of these questions wrong. Okay. This will hopefully help us rearrange the equation when we need it. So what I'm going to do is I'm actually going to tackle a couple of the questions in the booklet using that equation and showing you how it can be done. So if you look at this first one here, we are going to be calculating the size of organelles in this one and this one, and then we're going to be calculating the magnification of organelles in this one and this one. So let's do number one to start off with. I think we're going to go 1, 2, 3 and 4. They're not labelled in the booklet, but there you go. So let's do number 1 to start with. And it says that the magnification is 30,000 times, and it says calculate the size of the organelle. Right. So all we can do here is we can measure how long the mitochondrion is. And I reckon it is 8 centimetres, but I'm not going to use centimetres, I'm going to use millimetres. It is 80 millimetres. Okay. That's the length of the mitochondrion at its longest point. Now you need to think very carefully about what bit of information you've been given. Remember our triangle. Okay. Now we've either been given the image size, the magnification, or the actual size. Now a mitochondrion is not 80 millimeters long. They fit in your cells, they're small. So that means that it's not the actual size here. It's not a magnification, because magnification is not in millimeters. It has to be the image size. So this is I here. Now if I'm going to work out the actual size of an organelle, that's what I'm looking for, A. I must have been given one more bit of information. So look back at the picture. Yes, I have. I've been given the magnification there. M is equal to 30,000. Okay, so how do we arrive at A? So those of you who've used these triangles before, you'll know exactly what to do. You cover up the thing you're looking at. I've now got I over M. So A is equal to the image size divided by the magnification, which in this case is going to be 80 divided by 30,000. Okay, well, we can tap that into a calculator and see what we get. It's going to be a very, very small number, isn't it? So let's find out what that is. Okay, here's my calculator. 80 divided by 30,000. Okay, so 2.67 times 10 to the minus 3, so that's 0.00267. Okay, now what units were we in? Well, I gave my original length in millimeters, so that's millimeters there. But actually, millimeters are not a good unit for this. Look at all those zeros. That's not a sensible unit. So what I'm going to do is I'm actually going to convert it into a smaller unit. I'm going to convert it into micrometers. And the way you do that is you times it by 1,000. And as a result, you get 2.67. Now remember, the symbol for micrometers is that funny U thing. There you go. So I've now got my actual size as 2.67 micrometers. Okay, that is how you do these first ones here, calculating the size of organelles. So what I'll do now is I'll do one more worked example. I'm going to do this one where you're actually calculating the magnification. So that will be question 3. Okay, so as if by magic we've got a blank sheet of paper to work on. Here's question 3. Okay, it's asking for the magnification of these organelles. Basically, how much is this image here magnified? So just remember the triangle once again. Now, if I'm looking for magnification, then that means I must be given an image size and the actual size. So I'm looking for information on here that is an image size and actual size. Now, the first thing is, we've got a nucleus. It's obviously a nucleus. That's obviously a mitochondrion. But I don't know how big it is. So I can't really use the actual image itself. Like, there's no good me saying, oh, that's probably about 20 micrometers. I don't know how big that is. So there's actually nothing on here that is going to be of use to me. But let's look a little bit further, because we've got down here a scale bar. Now, this is something that students miss a lot of the time. That scale bar is going to help us solve this question, because it's got two things. It's got the actual length, but it also has an image size there. So let's think about this. This is saying that this bar from there to there would be 1 micrometer in length, but we've magnified it. So let's work out how big it actually is. Here is my ruler. It's 6 millimeters. Now that 6 millimeters is the image size. The actual size is equal to 1 micrometer. Now we have a problem here. That's in millimeters, that's in micrometers. They're not the same unit. I need to convert. So I'm going to convert the millimeters. Remember, converting millimeters to micrometers. These are smaller, so that means I'm going to have a lot of micrometers up here. I need to times by 1,000. So I've got 6,000 micrometers. Now they've asked me to find the magnification. That means I do my image divided by the actual. So that is going to be 6,000 divided by 1, which is 6,000 times. That's what my magnification is in this one. So remember, with these ones, if you're asked to find the magnification, look very closely if there is a scale bar. You're not expected to know the exact length of every mitochondrion out there. They usually provide this. This little bar here is part of the image. It's a tiny little length that's been enlarged, and therefore you see this little bar that was 1 micrometer, but it's been magnified the same amount as the rest of the picture. So don't ignore those. Okay, I hope that was useful, and now hopefully you should be able to tackle those two and arrive at some answers for them as well. Okay.